In 2008, a small architectural practice in the UK set out on an ambitious project in East London to demonstrate how timber might be an answer to the UK's desperate need for sustainable, high-density housing. The resulting 9-storey residential building is not only a pioneering example of 21st century architecture, but it leads the way for architects, engineers and developers around the world to build faster, cheaper and more sustainably, helping the fight against climate change.
The 9-storey building that we built in London, in the East End of London, is 8 stories of timber, 1 story of concrete, just the ground floor is concrete, then 8 stories above that of timber. It's a residential building with 29 apartments, and the timber that it's made from is like a jumbo plywood. So it's a plywood which is 150 mil thick. All the walls, all the floor slabs, the lifts, stairs, everything. We, as many other architects, are interested at the moment in looking at how we can reduce the impact of construction on the environment, how we can actually produce buildings, make buildings with a reduced level of CO2 emissions. Now, the obvious way to do that immediately is by, well, in the UK particularly, is by insulating, by looking at how you heat and light the building. But also, construction materials are a massive emitter of carbon dioxide. So, for instance, the production of concrete causes, I don't know, depends who you listen to, but between about 8 and 10% of all global emissions are just caused by the production of concrete. And that's compared to 1.6%, which is air travel. So, you know, people are always moaning about aeroplanes, but actually concrete's a really big deal. Concrete's a very big issue. So we're looking at ways in which we can replace the use of concrete with timber. Timber obviously being a replenishable material, but also a material that stores carbon dioxide within the material itself. I mean, it mostly is carbon. So you just grow more and you cut it down, you make bigger things out of it. And so we're looking at a viable way to replace concrete and steel with timber. Specifically, the different skills required are to do with the engineering and perhaps as well with the architecture. But in terms of the builders, in terms of the contractors, actually the skills are out there already. The skills of a carpenter remain the same. But it's, for an architect, for an engineer, that's the test really, because this is a new way of building. This is a different way of building from slabs and columns to actually building with flat pieces of timber, which work as beams, which work as floor slabs. So it's a different mindset for the architect and the engineer to really get into. We found with our building in London that actually, pound for pound, it was almost exactly the same as concrete. And that's when you're talking about a nascent technology, a technology right in its infancy. So when we have a technology that is faster, it's easier to work with, it's a more pleasant working environment, those issues alone should be making that technology cheaper and cheaper. The more people there are that manufacture this kind of material, then the cheaper it's going to get as well in turn. And unlike concrete, unlike masonry, this is a replenishable material. So once we cut some down, then we grow a little bit more. So in effect, it's got to be cheaper than digging things out of the ground that you can never get back. We're looking at changing the way, or proposing to change the way in which we build our buildings, in which we build our cities. The regulations, the way that contractors are set up, the understanding and the education of engineers and architects are geared towards a masonry and concrete culture. And what we need to do, what we need to look at, is how we can change that. So of course at the beginning it's very exciting, it's very interesting, but those codes, those ways of developing those buildings need to be really investigated from the word go, from scratch. The timber that we use for this technology is a farmed timber. It's a managed resource, and certainly in Canada, in Austria, where they have an awful lot of timber in those countries, they're using a very small amount of it. The amount of timber that we use for paper mills, for other technologies, really is not even taking full advantage of the timber. And importantly, timber as a carbon store actually only really is effective for the first half of the tree's life. So if you're taking a tree for, say, in Austria where a tree grows for 60 years, it soaks up carbon from the atmosphere for the first 25, 30 years of that. The rest of the time it's actually just in a cycle. So when you cut that tree down, you grow another one, you're soaking more carbon dioxide from the atmosphere into the tree. Every apartment sold off plan, before we'd even started building, in an hour and 15 minutes. And I think to our surprise and the surprise of the developer, those apartments sold primarily because they were built from timber. because people who had an interest in the environment, who had an ecological agenda, were going purposefully to buy those apartments that were made from timber.